9.2, the Pythagorean Theorem. Label the following parts of a right triangle on the diagram. The two legs. The two legs are actually interchangeable. You can choose which one you call A and which one you call B. I typically work from left to right, and I call this one leg A and this one leg B. That's personal choice. Now, the hypotenuse is across from the right angle. So first, let's mark the right angle, and the hypotenuse is across from it. So hypotenuse. Next, what is the Pythagorean theorem? If a triangle is a right triangle, then a square plus b square equals c square. Then we ask, what is the converse of the Pythagorean theorem? And that one says that if a square plus b square equals c square, then the triangle is a right triangle. And what is a Pythagorean triple? A Pythagorean triple is a set of positive integers a, b, and c so that a squared plus b squared equals c squared. There's no decimals. They have to be whole numbers. The most popular Pythagorean triples are 3, 4, 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25, plus their multiples. So if you multiplied by 2, then you would get 6, 8, and 10, 10, 24, 26, 16, 30, 34, 14, 48, 50. If you multiplied by 3, you would get 9, 12, and 15, and so forth and so on. We can use the Pythagorean theorem to find the missing side of a right triangle. Now we're going to use the Pythagorean theorem to solve for x. We have a squared plus b squared equals c squared. A is going to be side 6, and b, its measurement is 3. C is going to be x. So we substitute these values. We have 6 squared plus 3 squared equals x squared. 3 squared is 9. 6 squared is 36 equals x squared. 36 plus 9 is 45 equals x squared. Find the square root in order to get rid of the square, leaving x equals the square root of 45. Now that we can break that apart, so it becomes the square root of 9 times the square root of 5. The square root of 9 is 3. The square root of 5 is the square root of 5. And that equals x. Now that we've established the solution and what x is, what our side C is, we can say this is not a Pythagorean triple. And it's not because C is not an integer. Pause the video and do the next one on your own to determine if it is a Pythagorean triple. Let's do the same thing over again, the same way we did the last problem. So we have a squared plus b squared equals c squared. We're going to say a, b, and c. A is x squared plus b is 24 squared equals c, which is 26 squared. Now, let's go ahead and do our multiplying. 26 squared is 676. 24 squared is 576. x squared, we don't know. Subtract 576 from both sides. That will leave us with x squared equals 100. Find the square root. X is equal to the square root of 100, which is 10. So we can say, yes, it is a Pythagorean triple. In our next problem, a wire is used to support a 25-foot flagpole. So we have a flagpole, and a wire is used to support it. The wire connects 18 feet up the pole, 18.2 feet. So this is 18.2 feet, and that's this point. It extends in the opposite directions and attaches the ground 11 feet away from the base of the pole. So 11 feet out, this is 11 feet, this is 11 feet. We want to know how long is the wire. So we use the Pythagorean Theorem. A squared plus B squared equals C squared. We're going to make A this side, we're going to make B this side, and this one is C. So we have 18.2 square plus 11 square equals C squared. 18.2 squared is 331.24 plus 121 equals C squared, or X squared. We add these, we're going to get 452.24. So we find the square root. The square root of 452.24 is going to be 21.3 feet approximately. So 21.3 feet. We rounded it to the nearest tenth instead of stretching it out because our instructions tell us to round to the nearest tenth. Now pause the video, calculate these, and tell me if either are right triangles. One way that we can look at this, if you look at these three numbers, you notice that they're all divisible by 3. So 15 divided by 3 is 5. 9 divided by 3 is 3, and 12 divided by 3 is 4. So you can look at this and you can see that this is in fact a Pythagorean triple, which proves that yes, this is a right triangle. You can also do a squared plus b squared equals c squared. If you do this and they are equal, then it is in fact a right triangle. Now, a squared, that's going to give us this one, and this is b, and this is c. So a squared is 12 squared, which is 144, plus b squared, 9 squared is 81, and c squared, 15, is 225. And we're trying to determine if these are in fact equal. 144 plus 81 is 225. So that verifies that these are in fact equal to each other. Now, let's look at the second one. We have 9, this is going to be A, this is going to be B, and this is going to be C. We have 9 for A squared, and we have the square root of 115 squared. So 9 squared plus the square root of 115 squared equals 11 squared. That's our question. 9 squared is 81. The square root of 115 squared is going to give you 115. and 11 squared is 121. When you add 81 and 115, you're going to get 196, which is not equal to 121. So we can say that this is not a right triangle.